Question number 80 asks, what is the sine of angle B? Well, now we have an issue because now we're looking at angle B as the reference. The hypotenuse will never change, but now we see that side AB is now opposite of angle B, and side CB is adjacent. So I'm going to color code these. Let's do this. Let's make this vertex actually A. Let's change that to green. So you see the green letters go together with the vertex that is labeled in green. And then let's label angle B as dark blue. So you can see the dark blue side names correspond to angle B. Well, this is going to still be the hypotenuse. That doesn't change. But now side AB is now the opposite side, and side CB is now the adjacent side. So now for question number 80, what is sine of B? That's still going to be opposite over hypotenuse, but now the opposite side measure is 12, and the hypotenuse is 20. We can reduce that. Divide by, let's see, divide by 4. 12 divided by 4 is 3. 20 divided by 4 is 5. And we've got a ratio of 3 over 5. Put that in our calculator. 3 divided by 5, and that equals 0.6. So the sine of angle B is either 3/5 or 0.6. Let's go on to question number 81. What is cosine of A? Cosine of A, well, looking at SOHCAHTOA, cosine is adjacent over hypotenuse. So we're going to go ahead and write down cosine is adjacent over hypotenuse. Let's take a look at angle A and see what is adjacent. I think we know hypotenuse is going to be 20 every time. Let's go remember which side is adjacent to angle A. And angle A has an adjacent side of 12. So cosine of angle A is 12 over 20. Well, you can see, class, that's exactly the same as sine of angle B. So cosine of angle A is equal to 3 over 5, which is equal to 0.6. In fact, using trig with a right triangle, the sine of this angle will always be equal to the cosine of this angle, and vice versa. The sine of angle B will always be the same as the cosine of angle A. Let's take a look at cosine of B. Again, cosine is adjacent over hypotenuse. Let's take a look at the side adjacent to angle B. Adjacent to angle B is CB, which is 16. How about if we circle this just to show all the vertices have a circle around them? We've got 16 over 20, which is the same as sine of B. This is the same as sine of A, which was our first question. Sine of A was 16 over 20, same thing. Divide by 4, we get 4 over 5, and that is equal to 0.8. We'll continue with these last two questions on the next video.